So here we have a vehicle going around a curve. It weighs mass m, and width w, center of mass is at height h. The radius of the curve is r, and there is friction on it. Friction is mu, and that is static friction. So we're going to figure out, for the vehicle rounding the curve, is it going to slide first or tip first? And will that matter depending on whether it is a truck or a car? So we'll say for a car that h equals 1 meter, and for a truck, h equals 2 meters. The truck is taller. And then for the car, same mass equals 1,000 kilograms. And for the truck, mass equals 2,000 kilograms. For both of them, radius of the track equals 50 meters. And this width, W equals 2 meters. So let's say they're the same distance wide, but the truck is taller and it weighs more. And then friction equals 0.7. So we are going to calculate whether it slides first or tips first. So we want to see which one is going to be going faster for its maximum speeds. Okay, so procedure for these problems always is the same. Same as we have learned before. First is draw a free body diagram. Second is assign coordinate frame. Third is write equations of motion. So that will be sum of forces in the x, sum of forces in the y, sum of torques, and then 4 is solve. So first we'll work out for the car. So let's see, we'll draw the free body diagram. So here, we'll say we've got mg going down. These are the wheels of the car, so it's trying to slide out this way. So we'll have centripetal force, mv squared over r. We've got the friction force trying to hold it in, F mu. And then we've got the normal force. So if the car is trying to flip, it's going to try and flip that way. So we know that at the point right before it flips, the normal force is going to be acting on this point. Because if it's just going straight, you'll have half the normal force acting on each side. But as the car is starting to tip, then the normal force on the left side goes down, normal force on the right side goes up, until finally, when you're tipping, all of the normal force is on that same side, the tipping side. So next we assign the coordinate frame. So we'll say this is x. This is y. Then we need our equations. Sum of the forces in the y equals 0. N equals mg. And F mu equals mu mg. then sum of the forces in the x, we want that to equal 0 because that would be for sliding. For no slide, sum of the forces in the x equals 0, which is going to be mv squared over r minus mu mg. So the sliding speed, we get, well, we can cancel the m's. Then we get, v equals square root of mu g r. So v equals square root of 0.7 times 9.81 times 50. And that comes out to be 18.5 meters per second. So this is slide speed for the car. So now we're going to check tip speed. So to check tip, we're going to see what the torques are. So let's call that point O. So then sum of the torques equals 0. That is going to be mv squared over r times, we need to know this height now, which is given in the problem. So mv squared over r, because torque is force times distance. So we've got the centripetal force times the distance h. And then minus, let's see, well, then the force from the weight makes it torque. So that's mg times half of that width. So W over 2. And the friction force goes straight through the point of contact. So it does not create a torque. So then here we cancel the m's, and then we can get V equals GWR over 2H square rooted equals 22.1 meters per second. So this is for the car, velocity of flip. So since sliding velocity is lower than flipping velocity, it will mean that the car is going to slide before it flips. So car slide before flip, since V slide is less than V flip. Now for the truck, we will calculate and see if it is going to slide first or flip first, and how does that compare to the car. So for the truck, our free body diagram should look exactly the same, because we have the car sitting on the ground. So we've got mg, normal force, friction force, centripetal force. Okay, so free body diagram looks the same, but what changes is the dimensions and the mass. So we do sum of the forces in the y equals 0, n equals mg, f mu equals mu mg. And then for slide, we look at the x direction. Sum of the forces in the x equals 0 equals mv squared over r minus mu mg. So since we're working this out with formulas, it looks exactly the same as for the car. V equals square root of mu g r. Well, look at this. The mass does not come into the picture, and height does not come into the picture for sliding, because we've done this before with particle stuff. So for the sliding, the size doesn't actually matter. The truck versus the car, then it will still be the same answer, 18.5 meters per second slide for the truck. But if the size does matter, we have to look at flipping. So sum of the torques equals 0 equals mv squared over r, which is centripetal force times its distance, h, minus the torque from the weight, which is mg, times this distance here, which is w over 2. So the masses cancel. So again, mass doesn't matter here, but the height and the width do matter. So we said width was the same for both, but height was different. So V equals square root of GWR over 2H. And that equals 15.7 meters per second flip. So the truck is going to flip first. That makes sense with our reality check, because we know kind of intuitively if we're in a car, then chances of sliding are more. Like when you see NASCAR races, you know, the cars usually they're gonna drift before they flip over. And then for the truck, we know that if it's real tall, it's gonna be a lot more likely to flip when we're going around a bend than if we're in a low car, because the low center of gravity keeps you closer to the ground and helps you not to flip.